Alright, so 3.4D, this is going to be the last video from 3.4. We're going to talk about creating a line using slope-intercept. We're also going to talk about kind of comparing using the slope-intercept form to kind of create, kind of compare some information when we've got lines. So before we get to graphing, we're going to go real quickly through this. Parallel lines. Remember, this is from our description before. Parallel lines have slopes that are equal. Parallel lines, slopes equal. Lines that are perpendicular have slopes that are negative reciprocals, something like 2 over 1 and negative 1 over 2. So if we've got a line that's in the slope-intercept form, we can easily take a look at line A and line B and say, are they parallel, perpendicular, or neither? Remember, if they're parallel, then the slopes are equal. Perpendicular, slopes are negative reciprocals. Neither means, well, they just don't have anything really that's either the same slope or different slopes. So let's take a look at this here. Line number A, sorry. What's our slope? Remember, it's y equals mx plus b. What's our slope? Slope m equals 3. Line B, what's our slope? Slope, here's our line B. Line B, what's our slope? Slope m equals 3. So what do we know about these? Slopes are the same, so therefore these lines are parallel. Parallel lines. Sorry, that's kind of a Z, but parallel lines. How about these over here? What's our slope? Let's see. This one, the top one is solved for y, 1y. The bottom one is solved for 1y. So all this over here means that we've got a m slope in front of, is the number in front of our x variable. So here's my slope. Slope is 3/2. Slope here for the second term, 2/3. Let's see, well, are they the same? No, they're not the same, so therefore they're not parallel lines. Are they negative reciprocals? These are reciprocals, sure enough, 3/2 and 2/3, but they're not negative because that would mean that one would be negative, one would be positive. Because they're both positive, therefore these are really neither. They're not parallel and they're not perpendicular. So these are neither. How about over here? Again, set up for, the top line is set up for 1y, bottom line is set up in terms of 1y. So therefore the number that's in front of the x is the slope, number in front of the x is the slope. So therefore, what's our slope? Slope m is 3/2 over here. What's the slope in the bottom one? Negative 2/3. And sure enough, let's see, are these the same? They're not the same, so they're not parallel. Are they negative reciprocals? They are negative reciprocals because this one's positive, this one's negative, this one's 3/2, this one's 2/3. So they are negative reciprocals. So that means that these are perpendicular lines. So when it's set up, when these lines are set up in terms of y equals or the slope-intercept form, we can take a look at the slope real easily and say, well, if the slopes are the same, then we can say that they're parallel lines. If the slopes are negative reciprocals, then they're perpendicular lines. So it's kind of one nice feature about using the slope-intercept form. So this is the kind of the crux of 3.4D right now. So if we know the slope of a line and we know its y-intercept, in other words, if we're given the slope of a line and we know the y-intercept, we're given the y-intercept, then we can create the name of the line, or we can create the slope-intercept form of a line. So then therefore we can say for all of the points that are on the line, here's the description of the line. And this will be really helpful in Math 141 next semester when we have to kind of create a name of a line and kind of explain all the data based on that line. So here is our, I guess our question. Write an equation of the line whose slope is 2/3. All right, well, m is 2/3. Y-intercept is 0.8. Well, y-intercept happens when x equals 0, and we've got our b term here. So that means that here's our x term, here's our b term. b then equals 8. Well, sure enough, we've got all the information that we need to kind of fill out our y equals mx plus b format, because from the information we've given, or we are given, then we can fill in y equals m. Well, m is 2/3 x plus b. What's our b? 8. Well, sure enough, there is the description of a line, or the name of the line, or the equation of the line in slope-intercept form, because we've been given the slope and we've been given the intercept, and therefore we just create the line. So there's our answer. y equals 2/3 x plus 8 describes all the points on the line whose y-intercept is 0, 8 and whose slope is 2/3. Alright, so the next question then is write an equation of a line whose slope is -3 and goes through 0, -10. Alright, I'm going to pause the video and you guys can hopefully come up with that pretty quickly. So pause the video, come up with a line. Alright, well, the expression, or I guess the instructions say write an equation whose slope is -3. Well, that means that m equals -3, goes through 0, -10. Well, that means it's 0b. So b equals -10. All right, well, then write y equals mx plus b, because we can, if we know the slope and we know the b or the y-intercept, then therefore we can kind of plug some numbers in here. So y equals m -3x, because -3 goes over here because that's the slope, m, slope, plus -10, because that's our -10 is our b. So that's kind of the first step, and to make it a little prettier, we would just say that y equals -3x, that's the same, plus a -10, well, we can kind of say that that's just subtracting 10. Plus a -10 is just -10. So this is a little prettier mathematically. And we always want to be prettier mathematically. So there's our answer. Write the equation of a line. Slope is -3, goes through 0, -10. Well, there we go. There's our answer. All right. So sometimes, though, we've got to kind of do a little bit of a finagling to find out what the answer is here. So let's see. Here's our question. Write the equation of a line. Okay, well, that's kind of similar to what we've seen already. Slope of 2. All right, well, you know what? Slope means m. Slope is 2. Going through the point -3, 1. Well, shoot, you know what? That doesn't fit into our 0, comma b format, because -3 is not 0. So we got to throw that one kind of away, because we can't pull out the b, and the b is not really given to us. But what we can do is we can substitute in our slope of m equals 2. We can just plug that in right over here, and we can start that way. And we can say that well, we're going to start with y equals mx plus b. Y equals mx plus b, and just plug in m right there, because we know m is 2. And the only other information we're given is one of the coordinates here, x, and you know what, I'll change colors here too, just to make it clearer. We know that we've got an x and a y. Hang on 1 second, I'm going to green. We've got an x and a y right there. So if I know that for this equation, it's always going to be true if I put this point in there. And it'll give us more true information about the line if we put in this information in there. So I can plug in my y as 1. So I'm going to plug in y as 1. My 2 stays the same. The x we're going to plug in as -3, because we know that x is -3. And then the b right there is just going to be basically what we solved for. So we can just plug in some numbers and say now we've got 1 equals 2 times -3 plus b, and we can just solve for b, because b is the only variable here. This is like chapter 1 and chapter 2 stuff. So now we can just go from here down to here. 1 stays the same, equals -6 plus b, and we add 6 on the right side and add 6 on the left side to kind of cancel out the -6 over here, and we get b equals 7. So there's our b. We have to take a few extra steps to kind of calculate what our b is, or find out what our b is, but it's really not that difficult. So now we know that m equals 2 right here. Oops, m equals 2, and we also calculated that b equals 7, so we plug in from y equals mx plus b. Well, we plugged in the m as 2 and the b as 7, and sure enough, there's our formula of the line. And we're done. All right, we'll see you in class.